I loved it before, and then I realized how much of a pain in the butt.
All right.
Oh.
So I'm pretty sure
It's not
I'm like example 19.
19.
we finished 18.
Yeah.
Okay. Now I'm just gonna go back here. Oh, too much. All right. So remember this equation. All right. So the force of gravity is equal to the gravitational constant. I'm just gonna make this large. The gravitational constant times m1, m2. Right. Those are just two objects of mass over the radius squared. Okay. That's the equation we've kind of been using. All right. Look at this. Look at this. All right. That guy kind of looks pretty sad. He's like,
so tall.
He's kind of large.
That's Atlas.
he is kind of large.
Why is he on top?
Yeah, why is he on top?
top?
He's taking a break.
Have you ever heard the song "On Top of the World"?
It's 20.
Yeah.
He took a break.
Yeah.
Yeah, but is there a?
That's why everything went.
So what is
He
the
just doesn't
top?
North and south poles.
Oh,
But what makes the
He's
north
just
the top?
punching it with his feet.
Yeah.
I would not call the North Pole the top of the world.
Okay.
Isn't the
I would not actually call it because you know Earth is at an angle, right?
Yeah, it's like a weird football shape kind of.
So the North Pole is actually kind of over there.
But like, what if like we use the magnetic poles as a mark?
If we did that, if we did that, the North would be the top of the world.
Oh,
that's
So look at my picture.
right.
Yes.
But what makes it the top? Because you see in space, there is no up and down.
The magnetic.
No, it's wherever my feet are pointing. My feet are pointing down.
So you're saying that someone
Monkey
in
brain
Australia
It's
is
tricky.
effectively on top of there.
No.
All right. So I want to go over one or two examples
Australia is the down.
utilizing this equation. Okay. A physics student. That's you.
Let's go.
That's you guys. I mean, a Springboro physics student. I could change that.
Just change that O and then be like.
Absolutely. Now it's literally specific.
Oh.
Owen is flying an airplane. You want to be a pilot? You do today. All right. Owen is flying on an airplane 11,887 meters above ground. All right. So A says determine the force of gravitational attraction between Earth and the physics student if the distance of Earth's radius is 6.38 times 10 to the 6 meters. Okay. So if we look at this, we have a lot of information, okay? And this is, where's the pen? This is number 19. There we go. This is number 19. Let's see. Okay. Let's zoom in a little bit. Why is that pen going? Oh, too much. Actually, I'm just going to make that's fine. All right. Now my equation. Force equal to capital G M1 M2 over R squared, correct?
Yeah.
All right. Now, if we look at this, actually, you have all the information. I'm going to zoom this up. We look at this. I know my gravitational constant. All right. So my gravitational constant is 6.67 times 10 to the negative 11. Okay. I know that. Let's see. Mass 1. Does it matter which mass is which?
Nope.
No. All right. Let's just do Earth first. Mother Earth. Earth is 5.98 times 10 to the 24th, and then mass of the student is 70. So I got the top. Now the radius. Okay. So if we read this problem again, it says Owen is flying an airplane 11,887 above ground. So if we think about this, Owen is out here flying a plane. And from here to here, we said it was 11,887. And then it said to the center of the radius of Earth is 6.38 times 10 to the 6. What do I have to do to those two numbers? I have to add. Okay, if you add those two numbers, that will give you the radius. And solve for the force. Okay. What are you guys getting?
No, you forgot to square the radius. What? Or, yeah.
Oh, yeah, I did.
That's what I did. I did the same exact thing.
I got 683, 1 sig fig would be 700.
Yes.
685, 1 sig fig would be 700. Question.
Why is it you keep changing the mass of the Earth?
Does it keep changing?
So in that question, it's 5.98 times 10 to the 24. And then on question number 21, it's 5.97 times 10 to the 24.
That's great.
No.
Someone accelerate into space.
So little do we know, Earth keeps deteriorating.
At that
Yeah.
rate, yo, that's kind of scary.
I don't know.
And that's what,
I don't know. I didn't notice that. All right.
Oh no!
So
Wait, which is it?
Either.
yeah, it's probably somewhere in between.
Okay.
I mean, it is.
All right.
a big
So if we look at this, when it says find the acceleration that the student or find the acceleration of gravity that the student experiences. So solving for the acceleration of gravity, you just have force equals mass times acceleration. Now, when solving this, our final answer to A was 700 newtons, correct? However, our exact answer was 685, correct? So we should probably plug 685 into the force. Does that make sense? Okay. So 685 is equal to the mass of the student, mass of Owen, Owen's 70, times A. What you guys get? 10 using sig figs. What's your exact answer though? 9.7.
It would be 9.9.
What is it? 9.79.
9.785.
So what I want you guys to see is when a person's flying, right? He's flying above Earth. Okay. Oh, I wish I had my tilted axis. So Owen's up here. Thank you. Owen's up there. And we calculated gravity to be 9.79, 9.8. Okay. Gravity on Earth is 9.81.
Whoa.
So as you start to get farther away from Earth, it reaffirms the concept that the closer you are to the object, the stronger the gravitational pull. The farther you go, the less gravitational pull. All right, we kind of nailed that. Is there any questions on that? A lot of these questions kind of repeat themselves, so we're only going to do one more. Okay, we're going to do one more. Number 20.
Oh, Mr. Barr?
Yeah.
I mean, it's nothing major, but it's 10 meters per second squared, right? Acceleration.
Yep. You're exactly correct.
Thank you.
All right. Then number 20. Oh, I got the video.
Why is there a picture of a woman screen?
She's following that time.
All right. I think it was this video. We'll watch it. See, I've adapted. I just got to pull them up pre-class, you know?
Poor Pluto.
Wow.
Wow.
I know, I love it. Kind of crazy, right?
That makes me feel so insecure.
There's my,
Yeah, this makes me feel
there's my
worse.
healthy dose of existential.
I really,
Crazy stuff
There's
right
no
there.
point now.
I really don't.
Like,
Just think
Yeah,
right
have you
now.
guys ever seen that video before?
Oh, remember.
It's a pretty famous one. There's a better one?
There's one where like it keeps zooming out of Earth
Yeah.
just for like 3 minutes.
Well, I've seen one that starts at like a quark and then goes up to a proton, goes up to an atom, goes up
Yeah.
to like a cell, goes up to an artery, etc.
Yeah,
So I've seen that one.
yeah.
Anything smaller than quarks, no.
I thought that like I read something that said
What makes up a quark?
Oh.
Oh,
Oh.
boy, Adams. Yo.
Once you get down to
That's cycle.
What if there is a
I-
universe?
blank, then I'm kind of happy.
I don't even know that.
Quark was smallest in a different dimension.
What makes up a quark?
What if it is a universe?
Something quark is just like
That's a tough
It's
question.
made up like of
Well, can a quark change in a different dimension? Like, could there be something smaller than that in like the fourth dimension?
All right, let's check this one out. Let's check one more out. All right, so it says find the mass of Mars given its radius is 3.39 times 10 to the 6 meters, and that the acceleration of gravity on its surface is 3.73 meters per second squared. So let's check this out.
That's not Mars. It's definitely the moon, just red. Because it would have poles if it was Mars.
Yeah, that definitely.
Okay.
It's Mars for now.
I'm just saying.
All right. So find the mass of Mars given its radius and the acceleration due to gravity on its surface. Okay, it's 3.73. So we know the acceleration. Well, the acceleration is force equals mass times acceleration, right? Force of gravity is equal to mass times acceleration. Okay, but in this case, we also know that force of gravity is equal to G m1 m2 over r squared. So can we put those two equal to each other?
Oh,
Interesting.
man.
Let's try it out. So let's say the mass of Mars times the acceleration is equal to G, the mass of Mars, times the mass of just an object, right? It doesn't give us an object, but we know
Pick a number.
there has to be an object, over the radius squared. So it got it set up. Now, I like simplifying. If I have the mass of Mars on both sides, can they cancel? Yeah, let's just get rid of mass of Mars. So that leaves me with the acceleration, which I know is 3.73, is equal to G. I know G. You know G? I know G. Times 10 to the negative 11. Okay. Now, the mass of the second object actually. Yeah, we're good. And then over the radius. I did that backwards. This is the mass of the object. We're finding the mass of Mars. And this was the object. I did that a little backwards. Same answer though. All right, radius squared is 3.39 times 10 to the 6th. Does that kind of make sense how we did that? You just set these two equations equal to each other. You solve for m. What are you guys getting?
6.43 times 10 to the 23.
Perfect. 6.43 times 10 to the 23rd kilograms.
That's heavy.
Quite heavy.
Oh, and that shit.
You know what's wild is like people who bench or not bench, they do pull-ups with their beards.
Huh? I've seen
How
people
is
pull like.
I need to see that. I need to see
Yeah,
that.
wait, how do they do
Hold
that?
on, whatever we're doing next is not important.
They have their necks.
Is there any questions on how to do that? Did that kind of make sense?
My only question is honestly
Don't
someone
hurt
who
your
pulls
hair, I
up
guess.
all
Concept check. I want you guys to answer this. Don't yell it out. Two objects attract each other gravitationally. If the distance between their centers is cut by half, the gravitational force is just think about it. It'll take about 30 seconds. Everybody got their answer? How many people say A? How many people say B? How many people say C? How many people say D? How many people didn't vote? Oh, everybody voted? That's pretty awesome. All right, so this one's a little tricky. All right, this one's tricky. So if my equation is force is equal to gravitational 1 m2 over r squared. If the radius is cut in half, so you're going to have half the radius squared. All right, so you're going to have 1/2 squared. What's 1/2 squared? Oh man. Oh man. So you're gonna have 1/4 r squared, correct? So you're dividing by a fourth. When you divide by a fourth, what happens to the force? Quadruples, right? So instead of dividing by a fourth, it's actually the same as like multiplying by 4, right? You multiply by 4, and that multiplies that same by 4. All right, so the correct answer was D. Okay. Are we starting to get a little comfortable with this equation? All right, so we're not going to be able to get this done, but I do want you guys to get a start on it.
Can we at least see someone do pull-ups with a beard?
Yeah, I'm very.
Yeah.
confused
You really
how that
enticed
works.
us with
I
that.
really need to watch.
All right, I did come up and say it. That's
I think it's just gonna be a bunch of guys with beards doing pull-ups.
Oh.
Yo.
Never mind.
Never mind.
Never mind. We're good.
I don't know why I put a period there.
Period.
I don't want to hear that guy's speech.
The greatest speech ever. He's got some serious.
Yo, okay, that's a clickbait.
No, they're just only like 5 pounds each.
Exactly. He's lifting
Who's
weight.
gonna straight plastic?
He just throws it.
Maybe this
Yes.
was like a dream.
Yeah, are you sure this is real?
Watch. All right, hold on. I'm gonna stop.